Hi kids, in this video we'll continue with Upthrust in Fluids, Archimedes Principle and Floatation from class 9. This is from Concise Physics. I've already done the first part. You can click on the I button and get the link. In this particular video we'll discuss about density, relative density, determination of relative density of a solid by using Archimedes Principle and determination of relative density of a liquid by using Archimedes Principle. So let's get started. First thing, we'll talk about density. Now take a scenario where you take same volume of iron and wood. Same volume of iron and wood. The volume is same. Suppose the volume is V1 and V2. V1 equals to V2. Now, if you measure the mass of iron and wood having the same volume, we will see that, we will notice that mass of iron is greater than mass of wood, but the volumes are same. It simply means that the particles of iron are heavier, we can say, and particles of iron are closely packed as compared to particles of wood. In other way, we can say that iron is denser. Iron is denser than wood. Yes or no? They have the same volume, but the masses are different. Take another scenario. Take a scenario where we have taken, suppose, cotton and lead, and the masses are same. Suppose this is M1, M2, and M1 equals to M2. But still we will observe that the volumes are not same. We'll see that the volume of cotton will be more than volume of lead. If V2 is the volume of lead and V1 is the volume of cotton. So over here we have two bodies which have the same mass, but we see that their volume are different. Volume of cotton is more than volume of lead. This again means the same thing, that in lead, when we talk about lead, the particles of lead, particles in lead are more closely packed as compared to particle of cotton. That is why the volume of lead is less as compared to the volume of cotton, though the mass is same. This again leads to conclusion that lead is denser than cotton. Yes or no? So in this scenario we saw that two bodies have same volume but the masses are different. Two bodies have same masses but the volumes are different. This can be explained by density. We use density to explain this, and density is equal to mass of a body by volume occupied by the body. Mass by volume is known as density. Clear what is density? Now, when we talk about the unit of density, if you look carefully, mass is in CGS, I'm talking about, mass is measured in gram and volume in centimeter cube. So in CGS, the unit of density is gram per centimeter cube, and in SI if you talk about, then mass we know is calculated in kg and volume is calculated in meter cube, which means in SI unit density is the unit of density is kg per meter cube. So this is your CGS, this is a SI unit. And density is denoted by rho. Okay, this is the symbol rho, RHO. So rho equals to mass by volume. Density equals to mass per unit volume. Done. For example, if I tell you that density of iron is 7.8 gram per centimeter cube. It simply means that 1 centimeter cube of iron. What does it mean? What does this statement means? It means 1 centimeter cube of iron occupies or has a mass of, we can say has a mass of 7.8 gram. So if the density is 7.8 gram per centimeter cube, it simply means that 1 centimeter cube of iron has a mass of 7.8 gram. So the CGS unit and SI unit is given. We will try to look at the relation between CGS and SI unit. What I'll do, I'll just rub this part. Okay, just look over here. Now, the SI unit is kg per meter cube. Now 1 kg is how many grams? This is 1, this is 1. This is your SI unit. This is the SI unit. Now 1 kg is 1000 gram. Yes or no? And 1 meter cube is how many centimeter cube? Now 1 meter to centimeter, you multiply by 100. So you multiply by 100 3 times. Meter cube to centimeter cube. So 2 zeros, 1, 1. So 1 kg per meter cube is 1 by 1000 gram per centimeter cube. This is the relation between the SI and the CGS unit. We can write like this also. 1 gram per centimeter cube is equal to 1000 kg per meter cube. And that's the relation between the CGS and the SI unit of density. Clear? Now let us see the effect of temperature on the density of a body. I'll just rub this part. The effect of temperature on the density of a body. Sure. Just a second. Yeah. Done. Now look over here carefully. Now most of the substance, most of the solid, most of the body expand on heating, isn't it? And contracts on cooling. We know this. Most of the substance expand on heating and contract on cooling. So if you increase the temperature, suppose you increase the temperature, most of this body, most of the body, in most of the body, if you increase the temperature, the volume will increase. Yes or no? Definitely volume increases. Now, density is mass by volume. So if you increase the volume, the density will decrease, isn't it? So if you increase the temperature of a body, most of the body, the density decreases. Why? Because the volume increases. Expansion of solids, liquid and gases we have done, okay? Now, number 2. What happens when you decrease the temperature? Now, volume decreases, contracts on cooling, isn't it? Which means density equals to mass by volume. So if volume decreases, don't you think the value of density will increase because we are decreasing the denominator. So the whole fraction will increase, which means density increase. So for most of the solid, liquid or gases, whatever, which expand on heating and contract on cooling, if you increase the temperature, the density decreases of the body, and if you decrease the temperature, the density increases. But we need to discuss about water. Now, special mention for water. Now let us look at, we have all done in previous classes, anomalous expansion of water. What it was that if you decrease the temperature, look carefully for water, if we decrease the temperature of water up to 4 degrees centigrade, suppose it was at 50 degrees centigrade and we brought it to 4 degrees centigrade, we are decreasing, then what happened? Volume decreases. Remember, till 4 degrees centigrade, what happened? We'll see normal. You cool it, it contracts. You're lowering the temperature, it's contracting, the volume is decreasing. But if we decrease the temperature from 4 degrees Celsius to 0 degrees Celsius, see, in this case what happened? The volume decreases, that's normal. But from 4 degree to 0 degree, we'll see that the volume increases. Anomalous expansion of water. It should decrease because we are lowering the temperature, but it's increasing. Which means that, see, the volume is decreasing from here to 4 degrees centigrade. So up to 4 degrees centigrade, if you lower the temperature, what happens? Volume is decreasing, which means volume is decreasing. So the density will increase. Density will increase up till 4 degrees centigrade. So density at 50 will be less than density of at 4 degree. Why? Because the density keeps on increasing. But after 4 degree, what happens? After 4 degree, the volume is increasing. Now, if the volume is increasing, the density will decrease. Volume is increasing, density will decrease. Which gives us a very important thing, that water has a maximum density. Water has maximum density at 4 degrees centigrade due to anomalous expansion of water. Am I clear? Just be careful. Up till 4 degrees centigrade, the volume decreases. Volume decreases, but the density increases, keep on increasing. And then at 4 degree, after 4 degree, if you decrease the temperature, the volume increases, anomalous expansion. So the density decreases, which means the maximum density will be at 4 degree centigrade. So this was about density and the effect of temperature on density of a body. Now let us look at relative density. Now let us discuss about relative density. Now relative density of a substance RD is equal to density of the substance by density of water at 4 degrees centigrade. And remember one thing we missed. Density of water at 4 degrees centigrade, density of water is in CGS, it is 1 gram per centimeter cube, and in SI it is 1000 kg per meter cube. Okay, that is the value. And density is, of course, it's a scalar quantity. Now we look at relative density. Relative density is density of a substance by density of water at 4 degree Of course, it's a ratio, so it does not have a unit. No unit. Okay. Now, density of a substance, can I write mass of unit volume of substance by mass of unit? We can write volume of water at 4 degrees centigrade. Am I clear or not? Because density is mass per unit volume. Density is mass per unit volume. Okay. Now this we can write as mass of certain, we can write like this also, certain volume of substance by mass of same volume of water at 4 degrees centigrade. Yes or no? So that is relative density, which means relative density is equal to density of a substance by density of water at, rho means density, okay, at 4 degree, or you can say mass of certain volume of a substance by mass of same volume of water. That gives you the relative density of the substance. Clear? Now let us see the relationship between relative density and density of a substance. Now in CGS unit first, the relationship between density and relative density of a substance. Now relative density is density of the substance by density of water in CGS. Now in CGS, rho of water is 1 gram per centimeter cube, which means relative density is numerically equal to the density of the substance in CGS system, numerically, because relative density does not have a unit while density has a unit. And when you talk about SI system, now in SI system, if you look carefully, relative density is rho of S, density of, this is in gram per centimeter cube. This is in kg per meter cube. And rho of water. Now rho of water is 1000 kg per meter cube. So relative density equals to rho S by 1000. So relative density equals to rho S multiplied by 10 to the minus 3. Am I clear? That's the relationship between relative density and density of this substance in SI unit, and this is in CGS unit. Clear? Difference is very easy. You can between density and relative density. Relative density does not have a unit. Density has a unit. And write the definition. Relative density is the ratio between the density of the substance by density of water at 4 degree, whereas density is mass per unit of a substance. Clear? Now let us see how to determine the relative density of a solid using Archimedes principle. Now let us see how to determine the relative density of a solid substance using Archimedes principle. Now relative density, just now we did mass of the body by mass of water at 4 degrees centigrade of volume equal to the volume of the body. This is how you define a relative density of a body. Now using Archimedes principle, I can say that mass of water at 4 degrees centigrade of volume equal to the volume of the body is obtained. Be careful, just be careful and try to understand. Is obtained by finding the mass of water displaced by the body when it is immersed in water? Yes or no? Since we know that when a body is immersed in water, it displaces water equal to its volume. Yes or no? Now this becomes, by Archimedes principle, I can write mass of the body by mass of water of volume equal to the volume of body? I can write weight of the body by weight of water displaced by the body when it is immersed in it. Yes or no? And just remember the previous lesson. This we can write weight of the body, and just remember the previous chapter. Weight of the water displaced by the body is nothing but loss in weight of the body, which is equal to the upthrust. In the previous chapter we have done this. Yes or no? So this becomes, so RD becomes what? Weight of the body in air, suppose V1, by loss in weight of the body in water, which is, suppose I am taking V1 as the weight in air, and we know W1 as the weight in air and W2 as the weight in water. Then RD equals to weight of the body in air, which is W1, and loss in weight of the body in water will be W1 minus W2. So relative density using Archimedes principle, we can calculate like this: weight of the body in air by weight of the body in air minus weight of the body in water. Done. Now we look at two cases when the body has density more than water, okay, and it's insoluble in water. How to calculate the relative density? And the second case when the body has density, of course, more than water, but it is soluble in water. Then how to calculate the relative density? See, for the first one which I was talking about, first case, when the density of the body is, of course, is greater than water and it is insoluble. It is insoluble in water. Then relative density is this only, W1 by W1 minus W2. There is no change. When the body is insoluble in water, weight of the body in air by weight of body in air minus weight of the body in water. Now let us see what happens when the body is soluble in water. Then how to calculate the relative density of the body. Now let us see how to calculate the relative density of a solid which is denser than water and soluble in it. If it's insoluble, we know W1 by W1 minus W2. Weight in air by loss in weight in water. But suppose a solid is soluble, then what we'll do? We'll replace water with any liquid whose relative density is known to us. And the solid density is more than that of the liquid, so that it sinks in the liquid. Then relative density is equal to weight of the solid in air by loss of weight in the liquid multiplied by relative density of the liquid. Done. Remember this. This is when the solid is soluble in water. Done. Now let us see how to calculate, how to determine the relative density of a liquid using Archimedes principle. Now, relative density of a liquid will determine using Archimedes principle. Now, relative density of a liquid is weight of a given volume of liquid by weight of the same volume of water. That is relative density of a liquid. Now, by Archimedes principle, we know that whenever a body is immersed in water, it displaces liquid or water equal to its volume. Yes or no? Which means, can I write weight of a given volume of liquid? I can write weight of liquid displaced by the body by weight of water displaced by the body. Yes or no? We can write like this. And this is nothing, weight of liquid displaced by the body when it is immersed in it is nothing but loss in weight, isn't it? A loss in weight, suppose W1 was weight of the body in air, weight in air, W2 is weight in the liquid, and W3 is weight in water. The weight of the liquid displaced by the body is loss of weight in that liquid, which is W1 minus W2. Yes or no? Similarly, weight of water displaced by the body is nothing but loss of weight in water, which is W1 minus W3. So this is how we calculate the relative density of a liquid using Archimedes principle. W1 minus W2, W1 minus W3, where W1 is the weight of the body in air, W2 is the weight in liquid, W3 is the weight in water. We are finding the relative density of this liquid. Done. So in this video, keep it till here. In the next video, we'll see the next portion. Till then, take care and be safe. And if you like the video, do subscribe, share.